Hello everyone, this is Dr. K, and welcome to this week's module on component-based software development, or to put it another way, how to reason formally about your code. This module is divided into 4 parts. The first part talks about what a component is. The second part talks about both formal and informal specification. The third part shows how to reason formally about a simple code example, assuming that you already have a formal specification written for it. And the final part talks about the future of formal reasoning and the notion of a verifying compiler. So let's talk about components first. The idea of a software component isn't really that difficult to grasp because we see components in the physical world all the time. Here's a home theater system consisting of many components. We've got a big screen TV, speakers, a soundbar, an amplifier, receiver, DVD player, Blu-ray player, webcam, computer, and just many more components here. So what's the big deal about components? Well, as the name implies, components allow you to compose individual objects into a larger system. They allow you to replace or upgrade the individual parts of your system easily without having to replace or upgrade the entire system. Here's an incomplete list of some of the characteristics of a component. Components communicate with one another through interfaces. A software interfaces must, at a minimum, provide operation signatures for the component. It should also be thoroughly documented so that a client can figure out how to incorporate the component into their system. Components are cohesive. In other words, a component should ideally serve a single purpose. It should not take on multiple roles. A component should be substitutable for another component that implements the same interface. And a component should be able to be reused in many different systems. From the perspective of formal reasoning about components, this is perhaps the most important principle of component design. A component should be usable based solely on its specification. We'll talk more about exactly what a specification is in the next video, but for now, think of the specification as the interface plus the documentation for that interface. In Java, the easiest way to think of a component specification is to think of the Java doc for a specific interface. For example, when I want to use a list component in Java, I go to the Java API and look at the documentation for list. It tells me everything I need to know in order to use the Java list component, regardless of which implementation, like array list or linked list, that I will be using for it. It's not enough that components are well documented. Components should communicate with other components through well-defined interfaces. Consider this portion of a software system in which all modules represent concrete implementations, and therefore all of the modules depend on other concrete implementations. The linked list uses pointers in its implementation. That means that the hash map may have access to the pointers in the linked list. And if the hash map has access to them, then the symbol table potentially has access to them as well. Now, if we decide that we want to use an array-based list instead of a linked list in the implementation of our hash map, we run the risk of breaking everything that depends directly or indirectly on that linked list. Because the array-based list does not use pointers. In the very least, we have to retest our entire system to make sure we did not break anything that depended on the specific linked list implementation. On the other hand, if all of our components have interfaces, we can easily swap out a linked list for an array-based list in our system. And the only thing that we need to worry about is that our array-based list correctly implements the same interface that our linked list had implemented. And that concludes this video on components. In the next video, we'll talk about both informal and formal specification.